I could build 15 gigawatts of solar to hydrogen to replace the natural gas consumption in that commodity. The volume of solar to hydrogen is astonishing. If I'm able to do that, I don't have to connect to the electric grid to do it. I remove the constraint for solar. The growth rate of solar in the United States is directly tied to the interconnect, the ability to connect it to the grid, the speed with which we can ramp.
You know, we've heard for so long that hydrogen could be the energy source of the future, but perhaps today's guest made that future vision a reality. In this episode, we're highlighting a clip from my over 2-hour-long conversation with Jim Tyler, founder of Erthos. In the section I'm sharing today, we're discussing how hydrogen could replace natural gas. And to give you a quick background on Jim and Erthos, they've managed to make solar energy so cheap by laying the solar panels straight on the ground so that they can use that energy to generate hydrogen at such a cheap level they can now compete with energy sources like natural gas. We start the conversation by discussing how they're generating steam with hydrogen to power California's food industry, which heavily relies on natural gas. And then we move into the multiple use cases for hydrogen and how they plan to scale their hydrogen plus solar technology to the whole of America. You've had a lot of conversations with the buyers who pay for natural gas in California. Talk me through the economics then of offsetting natural gas for steam.
So you got to start with the price of natural gas at Henry Hub. Okay. That sets the price of natural gas for the world. Okay. The cheapest it's gotten down to is about $2. It got up to about $9
MMBTU.
A dollar per MMBTU. MMBTU can be converted to kilowatt hours, right, megawatt hours, but it got up to about 9 at the height of COVID and just after COVID. Yeah. But when you're at Henry Hub, that's the industrial price at that point, right? That's kind of like the nodal settling price. Mm-hmm.
There's still transportation price.
When you consume it at industrial consumers, at that final industrial consumer, big plants consume a lot of the natural gas. Right. In California, specifically for some of these industrial consumers, the average price over 2022 and 2023 was about $7 an MMBTU. You take that gas, you burn it in a boiler, and you make steam. Yeah. You lose efficiency through the boiler. Right. So you really got to look at the price of the steam instead of the price of the natural gas. Okay, so you got an efficiency conversion through the boiler. Right. So if the MMBTU dollar price is 7, the price of steam post-boiler is about 9. It's about, right? And 7 is a reasonable price.
Yeah. So you have to be able to deliver steam.
You got to be able to deliver steam at 9. If you deliver steam at 9 in California, you win. Yeah. Period. Because the price of food is ubiquitous. It's global. Yeah. Everyone buys food. Just because I can make it for this price doesn't mean I buy it for that price in the U.S., but the cost to make the food is very similar all around the world. California has to compete with the whole world for making food. Right. They do it well. Mm-hmm. It produces 25% of the world's tomato paste, for example. Mm-hmm. I know that number because of my history. But
higher percentage of that for milk, I think.
Milk is a larger commodity coming out of California. The energy demand to make tomato paste in California, just tomato paste, is between 12 and 15 gigawatts, 12 to 15 gigawatts equivalent of natural gas.
Oh my goodness.
The entire grid of California is 35 gigawatts. Just a single commodity consumes 35% of the equivalent of the entire electric grid in California. People go, what? No. Yes.
How can that be?
Yes, that's actually what it is. I could build 15 gigawatts of solar to hydrogen to replace the natural gas consumption in that commodity. Right. The volume of solar to hydrogen is astonishing. Yeah. If I'm able to do that, I don't have to connect to the electric grid to do it. I remove the constraint for solar. The growth rate of solar in the United States is directly tied to the interconnect, the ability to connect it to the grid, the speed with which we can ramp. It was 2 years. Now it's 4 and more on average. Mm-hmm. It's 4 in ERCOT. Yeah. It's more than that in most other places. That's a speed limit. If I don't have to connect it to the grid, if I can make the hydrogen off grid
on-prem
and then consume it, right? Especially if I don't have to transport it, if I can do it, locally made. So the California and Texas markets are exceptional for that.
Yeah.
Because plenty of sunlight in both places, lots of demand in both places for steam-based applications. Massive demand. Bigger than the total demand of electricity, right? So I recognized all that, and you start breaking these things down.
Yeah.
You get back the higher heating value of hydrogen. There's one other crazy thing that you get back. When you burn hydrogen and oxygen and you condense it, the boiler of a pure hydrogen oxygen boiler, that's another piece of magic. Nobody's ever made one. They never made one because hydrogen's too expensive. It didn't make sense to make one. So I go and got my background with the guys and people that I know from the industry and let's make one. We have one. We've got a 11,000 pound per hour boiler, 11,000 pounds an hour of water to steam. Convert 11,000 pounds of water
per hour
to steam in an hour. We have that boiler fully operational. Fully operational.
Can I see it?
Yes. It's in Sacramento.
Gotta go see it.
And it burns hydrox gas, hydrogen and oxygen together at about 45 psi. And it speeds up and slows down
based on the sunlight.
And I can directly replace the steam in the header with that at a price point significantly below $9 an MMBTU.
Okay, but food plants run 24/7.
Yeah.
So it's a dual coupling. You're offsetting the cost. You're lowering their annual cost, but you're not replacing the entire steam system.
So if you did it just while the sun shines, you're only going to replace so this is a summertime operation generally for that type, you're only going to replace about 25%, right? Nothing prevents you from taking those two gases, compressing them, putting them in a tank, and then using them 24 hours a day. Nothing prevents that. So, and that technology exists.
Sure.
Okay, so the pressure...
Betsy just worked at a company that has
the pressure of those tanks, there's an optimal pressure for those tanks. Run all the math. Here's the price of the tank and how much it stores and the compression ratios and all that type of stuff. About 300 bar, which is 300 times atmosphere, about 4,000 PSI. I can get 2 days of storage in a tank. The cost for those tanks, 2 days of storage per gas, 12 cents a watt. For 2 days, that's 48 hours of storage.
Right.
For 12 cents a watt for each gas. I'll let your brain run the math on that problem versus batteries. It's bananas. Compressed gas absolutely works. No question. Because I don't need to store it for 6 months.
Yeah, by the way, the reason people have said
effectively 2 days.
Hydrogen is an efficient battery, because that was one of the original, like 3, 4, or 5 years ago, the hydrogen boom is going to be a battery replacement, is because of the conversion losses. It didn't make sense. Why would we use hydrogen in the battery? We still have to convert it.
You run hydrogen compressors.
But if you
take what I'm describing at 99%, hydrogen oxygen compressors, you compress them, put them into those tanks. It only requires the equivalent of 2 days at peak production worth of storage.
But again, we're not talking about converting electrons DC to AC and then creating hydrogen and then converting the hydrogen back to electrons at some other point in the future.
You're combusting it to get the heat out of it in order to boil water to make steam to compete with. So here's the last little point, by the way, that boiler, when I was talking about that boiler, what's the efficiency of the boiler? The natural gas boiler, when you burn the natural gas, some of the energy goes out the stack. About 20% goes out the stack. The boiler I'm describing is fully insulated. And the only material that comes out of it is steam and the condensed water, back to liquid water.
Right.
There is no effluent at all, zero.
Is that condensed water distilled water?
It is. It's perfectly distilled water, and it has a name. It's called fire water. Kind of ironic name, but starts as fire, turns into water. We condense it. We get all that energy back. The efficiency of the boiler, 98%. I get 18% more energy back than the natural gas based.
Yeah.
I take that fire water, which is perfectly clean liquid water, and I put it back in the electrolyzer.
Yeah, of course.
Now I don't need new feed water for the electrolyzer. I fill the system up one time, closed loop.
Perfectly closed loop.
Perfectly closed loop. Now the electrolyzer does not build with contaminants.
Yes.
Because the water you put into the electrolyzer is not clean. It'll have a TDS of 60 or so. Over time, you have to clean the electrodes, right? You have to clean the diaphragm. If you're putting in perfectly clean water over and over and over, they don't contaminate. Reduces your O&M cost. So you got to put all of these things together, right? I can't go, oh, I'm going to buy this electro, I'm going to buy this part, I'm going to buy this part, and I'm going to be a developer who's going to develop a project and figure all these things out.
But a traditional solar developer is not going to figure this out.
Hell no. You need all these things.
The Venn diagram of raised in a household of a guy who works for Campbell's Food, early career in the food industry, over to silicon. Because we still haven't gotten to the important, like the key point. Like you're just talking about steam replacement as an economic justification for building an electrolyzer.
If you solve that problem of making the steam to make food, if you're able to financially solve that problem, which we have, you solve all the other problems.
Sure, it's economic justification for the rest of the problem.
The rest of the
rest of the machine.
So I can take that hydrogen that I would have made there, and I can refine it. I can put it into a really big PSA. Right? And make high purity hydrogen to make ammonia. No problem. The cost of that hydrogen will be about $1.50 a kilogram. The cost of brown hydrogen from, $4, $5 gas is about $1.40 a kilogram. I can make green high purity hydrogen right at parity with brown hydrogen from natural gas. Right at parity. Today. Absolutely. So now you unlock all of that, right? And everything I can take that high purity hydrogen, I can compress it, put in a car, and run the automobile, already existing automobile infrastructure.
1999 GM would be very happy with that.
The company that went bankrupt because of hydrogen would be very happy. Right? So you solve this problem, you solve all the others. So that's what the focus has been. I recognized this a long time ago. This was, 2.5, 3 years ago. So it took a long time to develop all these things. So we've developed the boiler. We developed the electrolyzer stack that's DC coupled and designed.
Created your own Erthos electrolyzer.
Created that structure from scratch, right? The infrastructure between it to compress it and all of that. Because these are off the shelf parts and pieces. We're not creating anything magic. And frankly, the electrolyzer, we didn't create anything magic there. We didn't invent a new material electrode to do this efficiency thing, or we didn't create a high frequency DC bump in the thing to cause electrons to bump free to increase the efficiency. We didn't do any of that shit. We didn't have to. We went to the fundamental, simplest forms. Stainless steel, the raw material, 316 stainless, at low temperature, low pressure, and high density polyethylene. The electrolyzer stack itself is so fundamentally simple that we get the cost so cheap that we can make it here in the US for extremely low prices. But do I want to sell the electrolyzer?
No.
No, that doesn't make sense at all.
Because you are a hydrogen company.
Sell hydrogen. Develop the hydrogen. I can't take all of this technology and go to Mr. Developer, who's developing a project of hydrogen. He's going to want to buy this company and this company and this company, and he's doing all that work. So it'd be very difficult for me to go, to sell to developers this idea.
And also they're going to try to commoditize your
That's right.
technology.
That's right.
They're going to make you compete with any other electrolyzer in the market. It's not the same.
It's not the same
apples to
thing.
apples.
It's not apples to apples. So if we sell hydrogen or sell steam, I can sell steam directly. Steam purchase agreement.
Does that exist?
They do. It's an interesting, there's companies, energy services companies that do steam purchase agreements.
Okay.
But one of the beauties of a steam purchase agreement, though, for this is the price of steam fluctuates based on the price of natural gas.
Of course.
The most you're going to get is 1 year ahead futures on natural gas purchases. Wow. So the price of natural gas can go up or down.
You can
and
stabilize CapEx or OpEx rather.
Flat. For food, the cost of electricity or energy is 15% of the cost of the food.
Of course. Makes sense.
And you stabilize it, make it flat.
Yeah.
In California, they can't burn any more natural gas. They're capped. 2022, AB 32.
How much is transportation component of the cost?
If you co-locate these plants, then the transportation's zero.
No, I meant of food, right? So 15% of the cost of food is electricity.
Oh, that's wild. It's all over the place. Depends on how far you ship it. And
because my assumption is the question is, then why would anybody create food in California at all? And the answer is because the raw materials are cheaper.
The land, the water, and the cost of natural gas.
Yeah.
Those three things, that's why they make it in California.
Got it. Well, that was just a brief snippet from the more than 150 minutes I spent interviewing Jim Tyler. In fact, I was with him the whole day at Erthos headquarters down in Arizona. If you want to learn more about Jim and Erthos and what they are up to, you can find the links to that full episode in the description of the podcast or wherever you happen to be watching or listening to this. I'd also encourage you to keep an eye out over the next few weeks as we'll be releasing more content from Jim and Erthos. And I'd love to take a moment to thank our sponsors who help ensure that this show is possible. They pay the bills, so all you have to pay is attention. I appreciate that you are doing your part. If you do a little extra, go check out our sponsors' offers at mysuncast.com/sponsor. Learn all about how they as well are changing the clean energy paradigm with their innovative technology. Hey, remember, you are what you listen to. Thanks again for showing up, Solar Warrior. It's half the battle.